Greetings, we're going to go over converting from decimal to hexadecimal. So let's say we want to do 1073 is our decimal number. Decimal hex, which is base 16. And just as a review real quick, because the question came up, right? Hexadecimal is hex, a decimal. So that's, you can think of hex as 6, right? Plus decimal, which is 10, so 16. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay? So that covers our number base, where it comes from. So let's do a conversion. Let's do 1073. This is a little different going from base 10 to base 16 than binary, but it's basically pulling out the largest values of 16. This time we're going to use division. So let's do some division. So first thing we do, this is one method, is 1073 divided by 16. How many times does 16 go into 1073? Right, so 67.0625 times, so equals 7.0625. Well, we want to capture this part as our remainder, but in base 16. So we're going to take 0.0625 times 16. So what does that equal? So I'm just getting down to, there's 0.0625, right? And I want that as in base 16 equals 1. So I capture that, R1. Okay? Now we take this value and we divide it again. 67 divided by 16 equals 4.1875. 4.1875. Again, we're interested in this value, and so we got to convert that. 0.1875 times 16 equals what? So 0.1875 times 16 equals remainder 3, and then finally we're down to just 4 now. So you can run through the same process, but since it's less than 16, you can figure out what the end run will be here, right? So 4 divided by 16, right? Just like we've done before, 4 divided by 16 equals 0.25. Well, there's no whole number here, so we just take 0.25 times 16. Well, that's just going to get us back to 4, where we were before. So we know remainder of 4. So this is our hexadecimal number right here, 431. So we say 1073 in hex is 431. So let's check that. So notice how we take the last value and put it first, and the first value and put it last. So now we can just check our work. So 1073 into hex is 431, or 431 in hex is decimal 1073. So let's go back the other way. Well, going back the other way is very similar to what we did in binary. So going back the other way, we just go like this. We say that we set up a table like I've done before, right? But this time we're base 16 or hexadecimal. So we're just going to go 16 to the 0th, 16 to the first, 16 to the second. Pardon me. 16 to the third, 16 to the fourth, and so on, right? And we're just going to take our values here and multiply them like we've done before. Oh, and then as you saw, I put a base 10 underneath this, right? So this is 1, 16, 256, right? So 16 times 16 is 256. 256. Okay, and then remember we have 4, 3, 1 here. So we have to take 4 times 256 plus 3 times 16 plus 1 times 1. So 4 times 256 and this is all going to be summed, plus 3 times 16 plus 1 times 1, right? So 1, 32, 48, so let's just check. So 16, 3, 48, and then 256 times 4, again, that's a pretty easy number, but just to demonstrate my work, 1024. And then we just add this all up, and it should get us back to this number. So 1 plus 48 plus 1024 is 10,073. So that's going back and forth between base 10 to hex, and then from hex back to base 10.